In this question, we are given the equation for the formation of urea. 2 moles of ammonia reacts with 1 mole of carbon dioxide to give 1 mole of urea and 1 mole of water. So for this question, in one process, 637.2 grams of ammonia is treated with 1142 grams of carbon dioxide. And the first part of the question is which of the two reactants is the limiting reagent. For limiting reagent questions, we have to first find out the number of moles of each reagent. So given the mass, we can find the number of moles by taking mass over mR. After doing the calculations, we see that we have 37.4148 moles of ammonia and 25.9492 moles of carbon dioxide. Let's take a look at the stoichiometric ratio that is required for the chemical reaction. If we look at the chemical equation, we can see that 2NH3 reacts with 1 CO2. So the stoichiometric ratio is 2:1. Now let's compare this with the moles of NH3 and CO2 that we have. We can start comparing using either reagent. So for this example, let's use moles of NH3 as a start. So from the equation, we know that the stoichiometric ratio is 2:1. Let me write that down. So if we have 37.4148 moles of NH3, how many moles of CO2 do we need? Let's write that down. So based on the mole ratio of 2:1, you would take 37.4148 divide by 2 for the number of moles of CO2. Now comparing the amount of moles of CO2 that we need with the amount of CO2 that we have, we can see that we actually have excess CO2. So therefore we say that CO2 is in excess and NH3 is the limiting reagent. Part 2 asks for the mass of urea form. To calculate the amount of product form, we need to base it on the limiting reactant. So earlier on in part A, we have seen that NH3 is the limiting reactant. So first of all, we need to look at the stoichiometric ratio between NH3 and urea. Based on the chemical equation, we see that 2 moles of NH3 will give rise to 1 mole of urea, and therefore the stoichiometric ratio is 2:1. In part A, we have already calculated the number of moles of NH3. So going by mole ratio, the moles of urea form would be the moles of NH3 divided by 2. So with the moles of urea form, we can now calculate the mass of urea by taking number of moles of urea times mR of urea. And we will get the answer 1123 grams. The next part of the question asks how much excess reagent in grams is left at the end of the reaction. We know that the excess reagent is carbon dioxide. So let's look at the information that we had in the question at the beginning. The question stated that we started with 1142 grams of carbon dioxide. Then in part A, we calculated that 37.4148 moles of ammonia, which is the limiting reactant, would react with 18.7074 moles of carbon dioxide. So since we know how many moles of carbon dioxide was reacted, let's calculate the mass of carbon dioxide that was reacted. We can calculate mass by taking mole times mR. Now that we know that 823 grams of carbon dioxide has reacted, we can calculate the excess reagent by taking 1142 grams of carbon dioxide minus 823 grams of carbon dioxide. And we get the answer 319 grams.